This short video lecture series is going to go through how to solve a series of titration problems involving a weak acid and a strong base. The problem we will specifically work through is the titration of 50 milliliters of a 0.10 molar solution of acetic acid with a 0.10 molar solution of sodium hydroxide. The acid dissociation constant, Ka of acetic acid, is 1.8 times 10 to the negative fifth molar. We will determine the pH of the solution at specific points within the titration. After 0 milliliters, 10, 25, 50, and 60 milliliters of the sodium hydroxide solution has been added. The approach and work to solve the various titration points will be presented in different videos that are all linked below. The first step for any titration problem is to determine how many moles of the acid are present in the solution. This is calculated by multiplying the concentration of the acid in solution by the volume of the solution, which for this problem is 0.10 molar times 50 milliliters, which gives us a result of 0.0050 moles. The first titration point for which we will calculate the pH is the starting pH of the titration before any of the base solution is added. Since none of the acetic acid will be consumed initially, we can treat this point as a simple weak acid equilibrium problem. The dominant reaction at this point will be the equilibrium reaction for the protonation of water by acetic acid. We should set up our ice table using the concentrations of acetic acid, acetate ion, and hydronium ion. Initially, we have in solution 0.10 molar acetic acid and no acetate or hydronium ion. Based on the equilibrium equation, for every mole of acetic acid that is consumed, we should produce a mole of acetate ion and a mole of hydronium ion. To signify this stoichiometry in the ice table, we will state that the concentration of acetic acid will decrease by x, and the concentration of both the acetate ion and the hydronium ion will increase by x. Now we can combine the values we have for the initial concentrations and the expected changes to give us equations for our equilibrium concentrations. We can set up our equilibrium expressions where Ka is equal to the concentration of hydronium ion times the concentration of acetate ion over the concentration of acetic acid. Plugging in the equilibrium values from the ice table gives us the mathematical equation 1.8 times 10 to the negative fifth is equal to x squared over 0.10 molar minus x. We can now solve for x by doing some algebraic manipulations of the equation and using the quadratic equation, which will give a value of x equal to 0.00135 molarity, which is then also the concentration of the hydronium ion. We can now solve for the pH by taking the negative log of the hydronium ion concentration, and a final result of 2.87 is what we'll get. This is the pH of the acetic acid solution prior to any addition of base.